All right, this is section 3.2, and we're going to talk about domain and range. So before we get into that, we're going to talk about inequality notation versus interval notation. Now, inequality notation is what you've seen forever with the less than, greater than, alligators, whatever people refer it to. I don't care if you use that unless a problem specifically asks for interval notation. You're welcome to use either. But I have found that some people find interval notation much easier. So essentially, interval notation, you're writing a coordinate and you're including the lowest possible value and the highest possible value. And then they're either going to have brackets or parentheses. And that's the difference between less than or less than and equal to. So inequality notation, if x was greater than a, let's say a was here on our graph. Greater than means it can't actually equal a, so we'd have an open circle, and then we'd have an arrow that pointed this way. If I were to write that in interval notation, the lowest value is a, and then it goes up forever, so that means it goes to infinity. Now the parentheses means it can't actually equal that number, so we would put that whole thing in parentheses. Now the difference between this and this is that greater than or equal to. So if I were graphing it, I would color in the circle because now I can actually equal a. And in my notation, I would put a bracket because I can equal the a. Infinity, you can never actually get to infinity. That's why that side stays a parentheses. All right, let's look at the next two. So if I put a here, so that is the difference between less than and equal to. They both get an arrow. And then in interval notation, they both go down forever. So they would start at negative infinity. And then they end at a, parentheses for the open circle, bracket for the closed or the equals to. So that part's kind of the same where the x's would be the infinity and so on and so forth. When it gets easier is when you have multiple endpoints. So if this one went from A to B, on a graph it would look like this. And then the one below it would be the same thing, just colored in. And the one below that, this one has no line, so that's open. This one has a line, so it's colored in. So they graph all the same minus those colored pieces. Then when I write them, they all start at A and end at B. So the first one has our open circles. The second one has our closed circles. And the bottom one has one of each. Now, a lot of people find that easier to writing because they don't have to think about the line and the not line and which direction. Again, it's up to you. The last one of these I want to show you. So if you have an or in between. Essentially, each of these would have its own graph. So if A was here, it would look like that. So that interval would look like that. The B would start somewhere and go up forever. And that interval would look like this. And the way you write or is this U, or a union symbol. That's just saying, hey, these meet. It can be part of either or on those arrows. So that's interval notation. Now I'm going to show you how we use that. Most functions that we graph are going to have a domain of negative infinity to infinity. So all real numbers. Essentially, if they have arrows on the end and they're continuous, meaning they never break, that's going to be the domain. The only time you really need to worry about that changing is if you have an even root or a fraction. So an even root means like a square root or a fourth root or a sixth root. And really with those, you can't have a negative underneath there because two negatives don't make a positive when you multiply. So any even root, you have to set greater than or equal to 0, which I'll show you. And then fractions, you can't have a 0 on the bottom. You can't have a 0 in the denominator. So we would have to figure out what would make that equal 0, because it can't be part of your domain. Denominator. Okay. So if we look at this first one, f of x, there's no root, there's no fraction, so our domain is going to be negative infinity to infinity. We don't have to do any math on that. G of x, we have a radical, we have a square root, so this piece can't be less than 0. So really what we're saying is 4x plus 2 has to be greater than or equal to 0. And then we solve that like a typical equation, or inequality in this case. So we subtract the 2 from both sides, we divide by 4, and that reduces to 1/2. So we get x is greater than or equal to negative 1/2. There's your inequality notation. If you wrote it in interval notation, it would look like this. Again, I don't care which one you write unless it specifically says, but that's how you figure out the domain with a radical. And then lastly, our fraction, we know the bottom cannot equal 0. So 2 minus x cannot equal 0. So we solve that. Subtract 2. I don't know what happened there. Divide by negative 1. And we get x cannot equal 2. So that's our inequality notation. And then an interval notation, that would look like those domains I showed you at the very end of 3-1, where you say it goes all the way up to 2, and then it goes past 2, but doesn't actually touch 2. You can do that on a graph. So if we make this our x and y axis, for our domain and range, we're just going to look at the graph. So the domain for this circle starts here, which would be 2, and it's a solid line. And then it ends here, which is about 3, 4, 5, 6, 7, 8.5. And again, it's a closed circle. So then I do my range. We start here, which is about 1.5. Again, we're just estimating. I can't zoom in and make it perfect. The top is 1, 2, 3, 4, 5, 6, 7, 8. So that would be the domain and the range on the graph. If our graph had an open circle or a closed circle, we still would do this same thing. So the domain goes from negative 0.5 up to about 2.5. And then we put a bracket on this end because of that colored in circle. Range, same thing. The bottom's colored in, so it's about negative 0.25, and it goes up to about 1.25, which would be a parentheses. And then the arrows, those are what tell us on the left and right that our domain is negative infinity to infinity. And our range, we just go where it bottoms out. This is going to be a minimum, which we'll talk about in another section, but it bottoms out at 1. So our range is from 1 to infinity. So those are some algebraic and graphic ways to find your domain and range. And the last part of this section we're going to talk about are piecewise functions. So they're just rules that they're functions that have different rules for different pieces or different parts. And we find those parts based on whatever restrictions are given in the equation. So this first part, we'll call it A, says x is less than or equal to 2. If that were interval notation, it would look like this. On a graph, I'm just going to bring this over here. On a graph, that means at 2, there'd be a wall, and everything in this section over here is where we would see the rule for A. B goes from 2 to 4. So if it was interval notation, it would look like this. And that one's going to be between those two lines. And then finally, C is when it's greater than 4. So C is going to be everything over here in this right section. So that's how those rules work, is they restrict your domains. Then, if we needed to graph it, we would just graph it like normal, but only draw the part that fits in the domain. So A, we have x plus 1, which means we have a y-intercept of 1 and a slope of 1. So we can go up 1 over 1, up 1 over 1 in both directions. And then we end at 2, and the bracket tells us to color it in. So we could connect A over here. B is 3, meaning no matter what the x value is, y is 3. We start with an open circle, we end with a closed. So this would be open, this would be closed, and those would connect. C, the y-intercept is 7, and our slope is -2. So we would go down 2 over 1, down 2 over 1, down 2 over 1, and so on and so forth. Now, because of this restriction, we don't start drawing until we get to that purple line. So that's the part we care about for C. So you can leave those yellow dots, you can erase them, whatever makes your life easier. But now those 3 lines are our graph. There's an arrow on this end, and there's an arrow on this end. So we know our domain's -infinity to infinity. We just need to check if there's any breaks in the graph. So this one's colored in, this one's colored in. So there's always an x value, so we can write that as our domain. If, let's say these had both been open circles here, we would have to do a second parentheses, but because one of them's closed, we don't have to worry about it. Our range goes down forever, and then the highest point on our graph is 3. So we can get that directly from the grid. Then our function notation is telling us when x equals 0, what's y? So we go to 0, y is 1. When x equals 2, what's y? So we go to 2, up to that point, y is 3. Oops. Then if we go at 3, it's 3. At 5, we go down to -3. And then the only times you really need to be careful are like 4, because it could be anything on that purple line. This is an open circle, so we ignore it. We only pay attention to the colored in circle. So that's what you want to focus on when you're looking at your graphs. So that is 3-2.